We've all been saying it, haven't we? The weather in the UK just feels wilder these days. We're seeing scorching heat waves one minute and then these massive disruptive storms the next. It really feels like something fundamental is changing. So today, we're going to dig into the data and figure out what this new reality of weather hazards in the UK really looks like. So let's just get right to it. This is the big question on everyone's mind. Is the UK's weather actually getting more extreme? Or is it just something we're noticing more? Well, that's exactly what we're here to unpack. All right, to get our heads around what's happening today, we've got to take a step back and look at the bigger picture. Let's start with the long-term shifts in the UK's climate. Okay, first things first, let's be clear on what we're talking about. What is extreme weather? It's not just a bit of extra rain or a chilly day. We're talking about conditions that are seriously severe or pop up at a weird time of year. Basically, it's anything that's a huge step away from the usual predictable pattern. And the data? Well, it shows a really clear trend. Just look at this number. In a little over 100 years, the UK's average temperature has gone up by almost a full degree Celsius. Now, I know what you're thinking. 1 degree, so what? But trust me, in climate terms, that is a huge deal with massive knock-on effects for our weather. And it's not just getting warmer, it's getting wetter too. On average, the UK is seeing about 5% more rain every year. And a big reason for that is pretty simple. A warmer atmosphere can hold more moisture. That means when it does rain, it's often in these really intense, short bursts. So why is our weather so changeable? Well, it's all about these giant blobs of air called air masses. Think of it like a battle in the skies. You've got polar continental air coming in from Siberia, bringing that bone-chilling dry cold. And then from the other side, you have tropical maritime air from the Atlantic, which is all mild and damp. It's the clash between these two that really dictates what we experience down here. And to see what happens when these forces collide in the most dramatic way possible, we're going to look at a textbook example of extreme weather. Let's break down the anatomy of the infamous Beast from the East back in 2018. So what kicked this whole thing off? It actually started miles above our heads, way up in the atmosphere. This quote here absolutely nails it. A rare event called sudden stratospheric warming basically shattered the jet stream. That fast-flowing river of air that usually acts like a shield protecting us from the coldest Siberian winds. This is just a fascinating chain of events. First, you get this crazy temperature spike. We're talking 50 degrees Celsius, 18 miles above the North Pole. That completely messes with the jet stream, weakening it, and letting that freezing Siberian air pour across Europe and into the UK. But that was only ingredient one. At the exact same time, Storm Emma was charging in from the Atlantic, loaded with moisture. And when that wet maritime air slammed into the freezing continental air, boom. You get the perfect recipe for a monster blizzard. Okay, so the science behind it is pretty mind-blowing. But what did this perfect storm actually feel like for people on the ground? Let's talk about the real-world impacts, when the entire country just froze. And we have to start with the most serious impact. It was truly severe, and tragically, there was a human cost. 10 deaths were directly attributed to this one storm. The amount of snow was just staggering. We're talking 0.5 meter. That's nearly 2 feet of snow on high ground. It just completely buried roads and cut off entire communities. And the cold? Wow, it was brutal. In some rural spots, the temperature dropped all the way to minus 12 degrees Celsius. Those are incredibly dangerous, life-threatening conditions. And what you see here is the incredible domino effect. It wasn't just about the snow. The whole country shuddered to a halt. Thousands of schools shut down, hundreds of flights were cancelled. You had people stranded in their cars on the M80 for 13 hours. It got so bad, the national grid issued a gas deficit warning. Supermarkets started running out of bread and milk, and eventually the military had to be deployed to help out. It was a genuine national crisis. Now, the Beast from the East was a cold extreme, right? But it's just one piece of a much, much bigger puzzle. So let's zoom back out and look at the most up-to-date evidence, which tells a story of extremes at both ends of the scale. And here it is, a moment that was genuinely historic. In 2022, for the very first time in recorded history, the UK hit 40 degrees Celsius. That's a temperature milestone that scientists thought was maybe decades away. And suddenly, here it was.
It was our new reality. Honestly, this chart just says it all, doesn't it? Take a look at the top 10 warmest years on record in the UK. Every single one of them has happened since the year 2000. That's not a fluke. That's not a coincidence. That is an undeniable trend. And if you compare the last decade to how things were in the late 20th century, the changes are just stark. Our average temperature is up by over a degree. Our winters are a massive 25% wetter. And yeah, we are getting a bit more sun, but those big, disruptive snow events, they're generally on the decline.
So what about storms then? Well, it's interesting. The long-term data suggests average wind speeds might be dropping a bit, but that doesn't tell the whole story. The frequency of major named storms is still a huge problem. Just look at the 2023-24 season. We had 12 named storms, the most in almost a decade, and they brought flooding and chaos right with them.
So after looking at all this, from record-breaking heat to record-breaking rain and all these disruptive storms, we have to come back to that first question. Is extreme now the new normal? All the evidence seems to be screaming yes. It suggests that what we used to call extreme is fast becoming our new baseline. And that leaves us with the most important question of all. What are we going to do to adapt?